All right, welcome everybody to the final demo presentations of the projects in the CSE 125 course. I'm really glad that everybody could make it out this afternoon to see the demos and see all the hard work that the students have put in this quarter to produce some pretty darn amazing things. So the CSE 125 is a relatively unique course that we offer here. It's not very traditional because the students are just assigned a single project that they work on for the entire quarter. And as you can see, the students have to be very self-motivated in working on this project. It's very underspecified. It's not as if I provide a whole bunch of rules and tutorials about what they need to do. I just say, do it. And then they have 10 weeks to try to finish it. And it's a course targeted for graduating seniors who have gone through the curriculum. We'd always do it in the spring, so these are students who are pretty much on the verge of heading off into the world after college. It's also a little bit unique in the sense that we have the projects work in relatively large groups of 5 to 6 people, which is a little bit larger than what students tend to work in other classes. And in particular, it's a type of project where one student cannot just rescue the entire team if sort of people drop out because of other reasons, other classes. So in other courses where the projects could possibly be done by one student, these projects cannot. So it really takes a team effort to be able to accomplish the projects in this course. They use a large number of tools. So in other courses where pretty much everything is done from scratch, for here, the game is done from scratch, but you use a whole suite of tools to help you out. Well, that wasn't so good. Oh, your stick fell. And then, pardon me, the staff fell. And then the projects, we're not just building things to make sure that they correct and pass a set of tests, and then you're graded and based upon how many tests you pass. These are projects that have very, very tough, stringent requirements. They're high-performance, real-time, distributed systems, and they're very, very difficult systems to build. And then finally, one aspect that I want the students to have is to have fun. And I think through most of the quarter that happens, perhaps, in the last week and when they spend all night, last night, working on these things, maybe the fun diminishes a little bit. But I think in the end, overall, they do have fun with it. I certainly do. And from my perspective, as the instructor, this is a course that's very, very easy to teach because I tell them that they have to implement a distributed real-time multiplayer 3D game, and we hand it out on the first day, and everything is due today, right now. And so this is, in effect, their final for this course. And in other courses where you sort of fill out a test and hand it in, nobody sees what happened. This is a final where you have a giant audience watching to see what happens. So the project is a game, but it's easy to forget that the games are very challenging applications to design and implement. It is known as the games course, but the title of the course is Software System Design and Implementation. And that's not an accident because in designing and implementing these projects, they're actually designing and implementing large, complex software systems. And there are many, many challenges to trying to make all this stuff work. It's distributed, so you have clients connecting to servers. Everybody has to be synchronized. It's real time because it's interactive. You're playing a game, interacting with other players. And then there's a tremendous amount of complexity from the graphics to networking, dealing with asynchronous communication, the sound, the animation, the input, all of that thrown in together, making it all work. But what's great about a game is that it's a project that also happens to be fun. So although it's very difficult, it's also fun to do. And it's also fun to play in the end. And this is a course that I really wish I could have taken in college. But nobody offered anything like this. And so when I came to UCSD, I decided to do the next best thing, which is offer the course so that students could do it themselves. And the course is structured roughly as follows. In the first week and a half, we have a couple of lectures, not too much, where we go over we introduce the course, talk about how it works and what's expected of the projects and things like that. And then there's a design phase where the students in the groups get together and decide what kind of game they want to build, what kind of features will it have, and roughly how they're going to try to piece things together to make it all work. And then the rest of the quarter is just implementing it all, trying to get it all working. They have an initial spec with a set of features. They have this game in their heads about how it is they want it to work. And then they have 8 weeks to try to start with essentially empty files and bring the game that they have in their heads into fruition so that they can play it and play it today. And during this phase, the way we structure the course is we no longer have lectures. We have some guest lectures come in, which is really great, from local game studios, and they provide a lot of exciting insight as to what's going on in the games industry today. But sort of roughly speaking, mechanistically, the TA, Jason Kimball, and I will meet with every group for 30 minutes every week, and we'll go over what they're doing, what they had planned to do for the week, what they are able to accomplish, what problems they have, and then provide some feedback and suggestions about how they should prioritize things and their time for the week following. And this entire process is documented on the project web pages, which is linked into the CSE 125 website. So if you're very curious to see where the game started and where they ended up, all of this stuff is documented week by week, including screenshots. So you can see at the very beginning what they started out with, and then in the very end, this week, right now, what they ended up with. And so you can sort of think of these project pages as sort of both a written and visual diary of the quarter. Now, one of the things that I ask them to do is to essentially every week comment on how they're feeling about the process that they're going through. And as you can imagine, sort of their feelings sort of ebb and flow depending upon where they are in the project and what else is going on in the quarter. And I just wanted to share with you some of the quotes that the students wrote on some of the status web pages. So, about halfway through, one of the groups was getting along pretty well, and they thought, well, maybe we should actually bring some other people in and see what the game looks like and get some feedback. And so, one student's feedback was, well, my goals for the week were to bring other people in to play the game while I spent my time working on other classes. That's not quite what I was imagining in terms of the attitude towards tackling this project and this course. But fortunately, somebody else in the group had a much more appropriate perspective on what I was hoping people would bring to the course. And then there are times when, lots of stuff is going on and things are getting a little bit crazy, and you start to wonder sort of what's going on in the background that you don't see as the students are interacting with each other outside of sort of adult supervision. As far as I know, no students were harmed in the taking of this course. Oh, that's right. Yeah. So Alan didn't quite make it through without a broken arm. So one thing that I really want to emphasize when you guys see these projects is that in every way, everything that you see, this is a product of the students themselves. In every way, the students make the class successful. It's not anything that I do. The project ideas are entirely their own. They solve all of the hard problems themselves, and they spent a long time doing it, and it's really difficult to do. They're working in a complex software environment, perhaps that they haven't really used too much before, lots of new tools, and not everything works. You might want to use a library that has a latest release, or you want to download something from the net, and that may have bugs as well, and you have to deal with trying to debug all of these issues. So when you see these demos, they really do reflect the outstanding abilities of the students, their independence, their initiative, and the problem-solving skills in trying to get all of this software to work in such a short amount of time. And from my perspective, I think of it as sort of the culmination of the students as they go through the curriculum that we offer here at UCSD, taking everything that they've learned over time, pulling it together, and making it work very, very well. So let me just give you a very, very quick run-through visually to see sort of how the quarter went, let's say, perhaps from my perspective. So at the very beginning, the students are very, very excited to start in the course. They got lots of smiles on their face, so there's lots of optimism. After all, how hard it could be to build a game. They've just been through all these other courses like compilers, which is really tough. So how hard could this be? And plus, they have 10 weeks to do it. In other courses, just 2 weeks to work on their projects. What could go wrong? How hard could it be? Well, about halfway through the quarter, the students reach this step, which is sort of a key milestone, which is integrating the different modules of the game together so that they interact together. So initially, students will, everybody sort of goes off a little bit and sort of implements independent modules, and then you reach this stage where you have to bring them together and actually try to make them work. And that is not always the easiest thing, and actually is one of the biggest steps and one of the biggest hurdles to get through during this course. And traditionally, that's when I leave. So, for whatever reason, it's not my fault. I have some trip that winds up getting planned that I absolutely have to go to, and it always overlaps sort of the toughest time of the quarter for the students. This year, I had my arm twisted. I had to go to the programming contest finals in Stockholm, and I had to have a really, really good time while doing that. It was very unfortunate, but instructors have to really, push on through all the hard stuff as well. And then towards the end of the quarter, something really magical happens. So at the very beginning, when the students are thinking about what it is that they want their game to be, they start sketching ideas. They start sort of mapping out how they think their code's going to be structured. And that sort of sets the seed for what the games are going to be. But it's still just sort of notes on paper, and it's really difficult to guess, to see what's going to happen. And then there reaches a time in the quarter, let's say roughly around 8th week, sometimes 9th week, sometimes 10th week, sometimes today, where you see the games one day, it's like, okay, yeah, things are working, and then the next day, there's just completely different. Everything has come together, everything is working really well, and they've produced something that's just incredibly magical. And that's what we're going to see today. And then at the very end, we have the final crunch. The students were up all night last night, getting last finishing touches, last bugs fixed, getting everything ready for today. Sometimes things go a little bit crazy. They start hating sandcastles and things like that. And then, before we launch into the demos, I just want to acknowledge a fair number of people who helped make this class very successful. So we essentially have a lab in the basement of the computer science building that is dedicated just to this course, and the Academic Computing Services does a really nice job in supporting us in all of the software that we need and making sure that we have the lab for our access. And then folks here at the CRCA and Cal IT2 and letting us use this space for the final demonstrations. And then we had 3 wonderful guest lecturers from local games companies throughout the quarter. And it's really great to be able to get, what do I know about games? So it's really great to get actual professionals who actually know what they're talking about in to talk about what's going on in games. And then finally, we get a whole bunch of software donated from Microsoft so that students can do all of their development on their desktops at home or on their laptops so they're not just tied to the lab. So from my perspective, I want the students to be able to be working in any place that they can at any time they can. And Microsoft is very generous in supporting that. And then one final acknowledgement that I'd really like to make is to thank the TA for the course, Jason Kimball, for all of the help he's provided to the students, because I don't know how to answer all the hard questions, and it's Jason who's the one who's there really helping the students out. So I just want to give Jason a round of applause and thanks. Okay, enough from me. Why don't we get the demo started? We have 3 games, 3 groups this year who are going to who took the course and going to demo, and the Wizards. Why don't you go ahead and get started?